Hello and welcome to Auto Tech Webinars. My name is Renato and this webinar is part one of our three-part series of a popular clinic that we have performed in the past, which is modern vehicle maintenance and common problems. So in this webinar series, we're going to discuss modern vehicle service trends. A lot of things have changed, new tips and tricks that we have to be aware of when tackling service issues on today's modern vehicles. And the second part is common problems, all the helpful tips and secrets we need to know about known issues on particular vehicles. So I hope you enjoy it, guys. So let's get cracking. So in this webinar, we're covering two topics. The first one is specific oil selection. As we all know, that old adage that we all grew up with on TV commercials, oils ain't oils. Well, we'll explain why, that not why one oil does not do every vehicle anymore. We'll discuss all the different standards, classifications and specifications as well. Also going to discuss the future of oil technology as well. Things are changing in regards to the base stock, the key ingredient that is used to make engine oil. After that, we're going to discuss the other new trend that some of us may have seen already, the inception of the digital service logbook. So on a lot of cars now, and more so in the future, no more service book in the glove box to stamp and fill out when we've completed the service. Now the logbook is theoretically stored on a database at the manufacturer. So what can we do about the digital logbook? Us private workshops, can we fill them out? What is the procedure to do so? Things like that will help you out there as well. All right, so let's get cracking and let's look at the first topic, specific oil selection. Why are there so many different oil specifications out there nowadays? Okay, so let's have a good look at this. The first thing I want to clarify for you guys are two popular terms that we commonly see when we're going to a lube guide to work out what type of oil are we putting in this car today. What we normally see on the lube guide is firstly the recommended oil. Now, this is the oil that the vehicle manufacturer is recommending for us to put in that engine. Now, as technicians, we would safely assume that if the manufacturer is recommending that specification, that viscosity oil, this must be the right oil for the engine to perform at its peak performance, kick out clean emissions, give good fuel consumption figures, and also ensure proper longevity and reliability of that engine. Now, yes, all good, valid points, and we think longevity would be the critical point, the critical factor for oil to sustain in that engine, but unfortunately that's further down the list. What's more important as far as manufacturers are concerned is, of course, very low fuel consumption figures and low emissions out the tailpipe to meet all the strict laws around the world. So unfortunately, reliability, longevity take a back step. So with that in mind, the fact that economy and emissions are their key priorities, that explains why car manufacturers are moving more so towards the lower viscosity oils, because the lower the viscosity, the less internal friction, which improves performance, reduces fuel consumption, and decreases the emissions at the back as well. So that's why they've been trending towards what has been called fuel efficient oils, low viscosity oils. And in recent years, they have taken that to the next level, moving now more so towards ultra low viscosity oils, even thinner than what we've seen before. So what exactly makes an oil ultra low viscosity? Well, it's an oil that has a high temperature, high shear rate, which is related to viscosity, which is less than 2.9 millipascals. That's not a whole lot of pressure, guys, to squeeze that protective oil film out of all the critical clearances of the engine. Much less pressure than what was needed before with the older type, higher viscosity oils. So as we know, an engine's not going to survive a very long time on such a high temperature, high shear rate. So of course that means they have to construct their engines a little bit different than what they used to. First important step, number one, yes, definitely they have closed up those critical tolerances inside the engine, because you've got a big clearance. That low viscosity oil isn't going to last there for a long time. What they've also done in for these instances, they've added a lot of anti-frictional coatings to the engine. So you may have seen diamond coated valve train components, so there's less internal friction there. We've seen anti-frictional coatings on piston skirts to help the protection there. They've even gone to the steps of polymer coated bearings. So that polymer embedded in the bearing material helps the gliding effect. So just in case that thin oil film has been squeezed out of that clearance, then the polymer keeps the engine from turning over. So yeah, making engines a whole lot different to put up with these thinner oils, which does increase the cost of manufacturing, but it definitely creates the benefit on the other end with emissions and economy rates out there. It helps them sell more cars at the end of the day. So engines are made differently to survive on such a thinner oil. Now, who actually controls oil around the world? Well, there is a committee that's in charge of this, and they are the EOLCS, the Engine Oil Licensing and Certification System. The good thing of having a committee controlling all the worldwide standards, all these ones here, and even the new trend, the ever-emerging manufacturer-specific oil standards, they test every oil standard around the world, and they test them all the same way with the standard test. The good thing about testing them the same way, it enables everyone to clearly see the comparative differences between all the standards of oil. Now, this was highlighted more so many, many years ago when manufacturers and technicians around the world discovered that this particular oil is good as a good standard for particular areas around the world. But when that oil is specified for the same car in another country, due to different driving styles, driving conditions, and different ambient temperatures, that international spec oil that actually doesn't do the right job in regards to engine protection, where the climate is different from the original country. So that's why the EOLCS was developed, in order to see if that oil standard, which is good for one continent, is okay for another continent. And if not, manufacturers had to adjust accordingly, so things work the way they should. It's a very good thing. So it keeps oil makers under control, keeps some standards in check, and it makes life a whole lot easier for us to compare one classification of oil against another, to ensure that we're actually putting the right oil in that car at every service. So here's the results of some of the tests. Basically what the test is an engine on an engine dyno, of course, and they're revving the engine with that oil in it under different loads, different RPMs, different ambient temperatures. And after this specific test run, they then analyze the oil and see how well it performs in 7 key performance indicators. So what are the 7 KPIs? Soot thickening, after treatment compatibility. Now that's all the exhaust after treatment emission devices. So we're talking catalytic converters, diesel particulate filters, the oxidation catalyst in front of the DPF, EGR valves, even GPFs, gasoline particulate filters, which we haven't seen yet in Australia, but we will see them very soon in the next couple of years. As you know, these particular devices don't like a lot of ash in the oil, so low ash oils would feature high in that indicator there. Then how well does the oil assist in improving fuel economy? How well does it prevent oxidation of the critical components inside the engine? How well does it prevent piston deposits, stopping sludge buildup in the crankcase? And of course, last but not least, how much does it assist in reducing internal wear and tear, which is what we really want from an oil. So they're the 7 KPIs that each oil is tested for under the same test. And what we can see here, guys, on the screen are the test results of 4 different standards of oil used around the world. So what the chart means, 0 is here in the middle of the chart. So if it scores a 0 in one of these KPIs, it does nothing for that indicator. If it scores up here in the 10s, then it's perfect, it's ideal. So as you can see, all these oils have tested out differently in their results. The blue one, which is taking up the most of that area, is an ASEA spec oil, and the fact that it's doing quite well in most of those indicators, sort of telling us it's a better quality oil, much more recommended for a lot of different applications. In light grey here is GM's Dexos 1 oil specification, where it's really good in some areas, but not too good in some of the other areas. But that's what the manufacturer wanted that oil to perform, to take care of these KPIs, and they weren't too fussed about the others at the end of the day. In dark grey are some of the many Volkswagen oil standards that they have released over the years. So dark grey here, so it's really good for that, does nothing for that, all of that at the end of the day, but not too bad in covering these KPIs. Finally, in yellow is an American API SN Plus standard, which is really good for oxidation, pretty average, if not really poor in some other areas as well. So looking at that chart, looks like the SN Plus oil has tested poorly against the others, especially against the ASEA oil, but it meets the standard for that manufacturer that wanted that oil. We only want to take care of these KPIs, and that's why they're specifying. Suits their cars, their driving styles, their climatic conditions. So clearly we can see, looking at these test results, that proves the old adage that oils ain't oils. Also proves to us why one oil does not do every car nowadays, and why we need to keep so many different oils on our shelves. It's good to know the background. All right, now let's have a look at all the different international oil standards around the world and the governing standards as well. I think the most important thing, as far as we're concerned, in regards to engine oils, are the viscosity ratings. As we know, there's the two numbers, the low temperature and the high temperature rate. So firstly, let's look who created the standard, and that was the good old Society of Automotive Engineers. Many, many years ago, they created the standards of engine oil viscosity. Basically, they create a certain thickness of oil and then they label it. This is a 0W, and then they make another batch of oil and say, this is a 10W, this is a 20, this is a 40, and so forth. By creating this standard, everyone that makes engine oil cannot deviate from these viscosity specifications. So it stops anyone out there from making a different oil, which might be thinner or thicker, but then calling it their version of a 0W. So all viscosity is the same, no matter what label or brand it is on the bottle. So that's good, keeps everyone in check, makes our life just a little bit easier. What they also dictated are the allowable viscosity grades for both low and high temperatures. So firstly, let's look at that first number, the low temperature viscosity grades, where the SAE mandated that you can't go any thinner than 0, and you can go up in 5 increments all the way up to 25W. That's the first number. The second number is the high temperature viscosity grades, where they say you start at a minimum of 20, going up in increments of 10 all the way up to 60. So it keeps them in check, stops a lot of manufacturers from doing anything different from everyone else, which does make our life a little bit harder. So that was all cool. That J300 standard stood the test of time for many, many years. But back in 2013, 7 years ago, the SAE had to go back and revisit the J300 because manufacturers were wanting to go to ultra low viscosity oils, very, very thin viscosities. Now, ultra low viscosity oils, they didn't have to change anything on the low temperature side, but they had to make some adjustments on the high temperature viscosity grades, where now they said, if you want to go ultra low viscosity, you can start with a 4W, going up with increments of 4 all the way up to 16. So yes, that means you can get something called a 0W4 oil, very, very thin stuff when it gets hot. Now, we won't see, I don't think we'll see a 0W4 oil specified for us in Australia because of our hotter climatic conditions. But one thing that is on the shelf and is recommended by some brands such as Subaru and BMW, you may have seen it, had to use it already, a 0W16 oil. You may have seen that or may have used that. So that means it's got a high temperature viscosity of 16, very, very thin. And that's just taking the fuel efficiency and the emission things to the next step, making the cars even more efficient and cleaner. with the lower viscosity there. Of course, to put up with that, these would be engines that would have electronically controlled oil pumps that can vary the oil pressure and volume to work with that low viscosity oil. So there is proper lubrication in the hotter climates and the hotter temperatures and the higher RPM. All those extra things they have to do to make it survive on such a thin oil. So SAE controls the viscosity and keeps everyone in check that way. Now let's look at the international standards. Firstly, API. So this originated in America, mainly based for American-made vehicles, but as you have seen over the years, is a worldwide standard that some manufacturers may choose to use as their benchmark. So firstly, let's look at API petrol grades, the old S classification. The current API petrol standard is SN+. So it's the former SN standard with some slight revisions. What's different from SN+ to the former SN? It's been released and it also now encompasses these ultra low viscosity oils, these 0W16s, because SN didn't cover ultra low viscosity oil. So that's in SN+. The other thing about SN+ oil, to meet this standard, it means that the oil has been tested for and has passed what is called the LSPI test, low speed pre-ignition, which is a pretty big problem for today's high-tech petrol engines. I'll talk about that at the end of this topic. So if it meets SN+, it's been checked and ticked off. Yes, it prevents LSPI to a certain extent. Now, API diesel specs. There's currently two different API diesel specs out there working concurrently, side by side. Firstly, there's CK4. CK4 spec covers all the older diesel engines, things 5 years old or older, so it's a slightly higher viscosity. But what is also out at the same time now is API spec FA4. FA4 covers all newer diesel engines less than 5 years old. What's the difference between the two? FA4 is a very low viscosity. It's fuel efficient, ultra low viscosity oils that they want us to use in their car now. Because it's so thin, it really can't be used in older engines. So that's why we have two standards. CK4, slightly thicker for older diesels, FA4 for today's diesels. And because it's so thin, it's not backwards compatible. That's the other reason why we have to have two standards out at the same time. You wouldn't be putting FA4 in a pre-1990 diesel. It's just way too thin. It's just not going to work on that type of engine. And the formulation, there'll be some key ingredients that might be lacking, which makes it not suitable for the older stuff. All right, let's move over to Japan, where Japan had been using JASO as their performance index for many, many years, but not so much so nowadays. Nowadays, JASO, which is just for Japanese diesels, not for Japanese petrol engines, is now only a performance index specified by Mazda and Mitsubishi. The other Japanese car makers have moved over to another well-known performance index. So Mazda and Mitsubishi currently, DL1 is normally on a lot of their diesel vehicles the recommended performance index that you need to abide by when you're choosing an oil for them. So not many manufacturers using JASO as their benchmark anymore. Now let's move over to ILSAC. ILSAC came out back in 1998. I remember being a technician back then, and all this talk came out. Here's a new oil grade. This is what it's all about. Basically, what ILSAC is and why it was developed, it's basically a joint collaboration between the Japanese and the American car industries. Because what was happening in the 80s and the early 90s, especially with a lot of Japanese imported vehicles going into the American market, because the Japanese had one performance index and the Americans had their own performance index, some technicians didn't really look at the classifications or their lube guides too well, and they were putting American spec oil in Japanese cars. And it wasn't suitable. It was causing a lot of Japanese vehicle engine problems, a lot of customer dissatisfaction, warranty claims on those brands and really hurt sales. And to a certain effect was happening the other way around as well, because some American cars end up on the Japanese roads as well, and Japanese techs were doing the same thing in regards to putting the wrong oil. So they got together and said, can we have a blanket petrol engine standard, ILSAC's only for petrol, that works for both of us and prevents any more confusion? So that's what they did, and that's why ILSAC was created. The latest ILSAC petrol oil specification is GF5, very popular spec, recommended by a lot of manufacturers, especially GM cars that we have seen over here in Australia. GF5 is backwards compatible, so it will cover all engines that say from GF1 to GF5. You can put GF5 in there. But what has slightly changed in the formulation between those specs over the years, GF4 and the current GF5 now have less ZDDP than GF1 to GF3 spec oils. What's ZDDP? The magic ingredient, that is zinc. Zinc must be in your oil if you're running what is called a flat tapper engine, an engine that has got a mechanical valve train, no roller valve train, cam followers or roller rockers and things like that. So where you've got those high scrub surfaces between the cam and the cam follower, you must have zinc in that critical area, or else you will not have any cam lobes left. So zinc is great for that, must be in there. But unfortunately, the problem with zinc, it creates excessive emissions at the tailpipe. So that's why they've been trying to reduce it or get rid of it over the years. So what they did with GF4 and GF5, they have reduced the zinc content, but it's still backwards compatible to a certain extent. You might want to add a zinc additive on something very old running that type of oil. So that's where they're at the moment with ILSAC, but changes are happening as we speak. Very soon, GF5 will be replaced by GF6A. Still backwards compatible, but reduced amounts of zinc in it. Now, when GF6A comes out, they will also release GF6B at the same time. Once again, two oil specs released concurrently. What's the difference between 6A and 6B? 6B has no ZDDP in it at all. No zinc, so you definitely wouldn't be putting a GF6B spec oil in a car that said, I'll use GF1 to GF5, because there's no zinc left. You'll have a flat cam very quickly. So it's not backwards compatible. That's why we need the 6A and 6B working side by side. 6A for the old stuff, 6B for today's stuff. The other different thing about 6B, it's also going to encompass ultra low viscosity oil, 0W4, 0W8, 0W16, all those sort of things. So everything running GF6B onwards will definitely have a rollarized valve train in that area, because there is no zinc left. So that's happening very soon, this change. You'll start seeing it very shortly in your workshops and your lube guides. All right, let's move over to ASEA. So this is an oil specification that originated from Europe and has been highly regarded and used over there by many European car makers, and now some Japanese car makers as well. If they're not using ILSAC and they've moved away from JSO, they're using ASEA as their benchmark. Now, we've used ASEA oils a lot already, I can presume, via mountain cars that this spec covers. And we've always seen these letters and numbers after the ASEA oil grade. So what do these mean? Well, it breaks the ASEA oils into 4 different groups. So if you see it's an ASEA A engine, that is a petrol engine oil, older petrol engine oil. ASEA B oils are for light duty diesel engines pre-DPF. ASEA C oils are for petrol and diesel engines with a catalytic converter, so 1986 onwards, and a diesel engine with a DPF, so it's a lower ash oil, which these devices mandate. E is for heavy duty diesel engines, so for truck engines. But in saying that, it's also Isuzu D-Max. It's an ASEA E oil they recommend. Why? Because Isuzu make trucks, and they just carried over their truck oil viscosity knowledge over to their light commercial ute as well. And it is DPF compatible at this stage. So that's what the letters mean. Breaks it down in 4 groups, tells us exactly what type of engines it's suitable for. Now, after that letter, there's usually a number that goes from 1 to 9, and that relates to the high temperature, high shear rate, which is the viscosity. Now, there is no rule of thumb. You might be thinking, oh, 1 is the thinnest oil and 9 is the thickest oil. Not so much the case. It's something that's all over the place. There is a chart. If you get the training manual for this clinic, it's on page 6 for future reference. You'll see the chart there. But something to keep in the back of your mind if you're trying to make a quick oil selection off the top of your head. With these numbers after the ASEA oil group letter, if it's number 1, 2, or 5, these are the newer high temperature, high shear rate, the ultra low viscosity oils. So if it's a not 1, 2, or 5 oil grade, then it's a slightly thicker viscosity, mainly for the older vehicles out there. That's one quick rule of thumb that you can use in this particular area. Okay, so that's the international standards that we've seen of use, where they've originated from, and what is the current standard out there. But what we have seen, guys, we've seen various car makers move away from those international standards and create an oil classification of their own, manufacturer specific oil specifications. Why are they doing that? I'll explain why they do that very shortly. But what these manufacturers have done, like Volkswagen over the years, GM when they brought out Dexos, Ford's doing it, other manufacturers are doing it. If not, they're going to do it for sure. Basically, they look at the engine oil classifications available out there, all those international ones, and they look at the formulation and they say, yep, it's not bad, it's close, but it's not perfect. It's not ideal for our engines because of the metals we use, the anti-frictional coatings, the plastics inside the engines as well. That's important as well nowadays. We want a different chemical. We want a slightly different formulation from what is currently out there. So what they do, they go to the oil manufacturer that they use and they say, yep, we like this particular grade of oil, but can you add a bit of this and can you reduce a bit of that in the formulation? So it's a custom oil blend that the manufacturer wants. Now, the oil maker would be obliging because, you know, they get the business from that car maker. So they will play around with things, add some ingredients, take some ingredients out, and now it's a slightly different oil, this custom blend. And because it's slightly different from one of these international specs that are currently out there, the manufacturer gives it their own manufacturer specified classification. So yes, that's where it comes from. They're allowed to do it, that's for sure. Some of us out there in the industry think this is just another step of dealer exclusivity, making people buy genuine oil. Yeah, that could be true to a certain extent, but you know, if you're checking your lube guides and the oil makers say it meets this spec, it meets that spec, it should do the job for you without too much of an issue. What the manufacturer also wants, and the reason why they want specific additives added or removed, because they're worried about the timing chain life. So they might want some key ingredients added to make that timing chain last a little bit longer. And also some other wear tests, such as LSPI, low speed pre-ignition. Does it stop that? Add or take some chemicals out for that as well, which I'll talk about very shortly. So that's why we're starting to see the emergence of manufacturer-specific oil. So it's the perfect oil blend to suit their engines for what they want it to do and help this engine last the warranty period at the end of the day. So let's talk about something I've been harping on a little bit, low-speed pre-ignition. This turned out to be a very big problem for today's high-tech petrol engines. Started rearing its head in late 2000s, about 2008, 2009. That's when we started seeing more and more downsize efficiency engines. So these small petrol engines, small capacity, 3 4-cylinder engines with direct petrol injection and supercharging on top, whether it's a supercharger or turbocharger, forced induction system, I should say. So highly stressed engines, and you've probably saw them over the years. Volkswagen was very notorious for this. A lot of these engines very early in the piece were basically blowing up, exploding. So failed engines going back to the manufacturer or back to our workshops, and normally piston failure was discovered when they dismantled the engines. Broken ring lands, broken piston rings, cracked pistons as well. All these things were servicing them up. So because it was happening a lot and a lot of unhappy customers, a lot of warranty claims, fights in the courts, things like that, car makers had to sort of work out what the hell was going on here. What's, we designed this engine, it should be right, but things are going wrong. So firstly, car makers were blaming car owners for not using the right octane fuel, which could be valid to a certain extent. But when they went back and did further testing of these engines, they realized there was another problem occurring: low speed pre-ignition. So what LSPI actually is, under the very highest demand condition of the engine, that's when you go from low RPM, you're going up a hill, high load, and you put your foot down to the floor, the highest load that engine's going to get, the engine starts detonating away in that critical period. And of course, the pistons or the rings will suffer and fail from that. Now, this low speed pre-ignition was uncontrollable. A lot of us are thinking, well, what are the NOx sensors doing? Well, NOx sensors are only going to help the ECU retard the timing if the ignition system is causing the pre-ignition. But this is not because of the valve, the ignition timing. There was something causing it in that high-low condition for the cylinders to get too hot and start firing on their own before the spark plugs even tried. So even if the ECU got told by the NOx sensors that it was knocking away, retarding the ignition timing wasn't going to stop this, and that's why they subsequently failed. So they realized this low-speed pre-ignition issue was going on out there on the roads. And what they actually found, apart from the excuse of wrong octane fuel, that there was something in the oil formulation that was causing LSPI. Ended up being calcium. Now, you'll find calcium in almost every engine oil out there, because calcium is a detergent to help neutralize all the acids from blow-by. So, it's a byproduct from combustion, and the calcium acts as a detergent, keeps your crankcase clean. Unfortunately, in those high temperature situations in the combustion chamber, when that high load scenario was occurring, calcium actually ignites and was causing this pre-ignition. So once engineers realized it was the calcium causing LSPI, they went running back to the oil makers and said, hey, you got to get rid of the calcium. You got to find another alternative for a detergent in their oil. So oil companies went back, did some tests, tried some things, and they came back and said, yep, we got it. We can get rid of the calcium, and we'll now use molybdenum instead as the detergent. So moly doesn't create LSPI, doesn't ignite when it gets hot in there, unlike calcium, and does an acceptable job as a detergent in our oils. So, you can safely assume, guys, when you're looking at your oil specs and your classifications and you can see that it's passed the LSPI test, guaranteed to assume that they got rid of the calcium in that oil and it's got molybdenum instead to act as the detergent, which is always handy to know. What they also realized, what was causing LSPI, is the base stock, the key ingredient of that engine oil. As you know, originally oils were made from crude oil, stuff that comes out of the ground. Now, no matter how well or how hard they refine that crude oil, there's always going to be some impurities in the oil that they just couldn't take out, which at the end of the day make it not the ideal lubricant to put inside of those engines. And those impurities hurt performance, hurt friction, hurt engine longevity. And that's why we started seeing more and more synthetic oils out there. Synthetics, man-made in a laboratory, it's a pure lubricating oil. It's got no impurities. It's perfect and ideal for all engine conditions. And that's great, but as we know, synthetics are very, very expensive oils. There's also a downside to it. There's been a lot of talk or studies performed that synthetic manufacturing at factories creates a hell of a lot of emissions out to the atmosphere. So they're getting a bad rap for that as well. So dirty to the environment, very expensive. A lot of manufacturers are trying to curtail how much synthetics actually use in their oils. So that led to engineers to look at alternative base stocks for oil. So what's happening, what is emerging, you're going to start seeing more and more of them, bio-engine oil as the base stock. So when they say it's a bio oil, normally it's in a green bottle to show that it's environmentally friendly, it's less pollution to make and then use in our engines. They're using natural ingredients as the base stock. So no crude oil, no synthetics, things like sugarcane or even corn, depending on which country this bio-engine oil is made and what resources they have available to them. So yeah, just like biofuels, bio-engine oils. So it's a bit cleaner, less impurities, cheaper than synthetics. Now, it's not perfect. It's not going to be the perfect engine oil lubricant. So what they then have to do is add a certain level of synthetics to make up for the shortfalls of this bio-engine oil. So not as many synthetics as before, but much less, cheaper and cleaner to make that oil in the future. So start getting used to it. You might see more and more bio-engine oils available for us to use as well. So look out for that. And LSPI, let's stay on top of that. So it does create too much pressure when there's low speed pre-ignition, causing pistons and rings to crack. All right, so that's enough about specific oil selection. Hopefully that explains a few things, a few questions that you may have had about why is there so many different oils, why there's so many different grades. Hopefully that's a whole lot clearer for you guys. Okay, so now let's move on to the digital service logbook. So you may have come across a vehicle already. Customers dropped off the car, and what we normally do, we go to the car with the job card, we write down the mileage off the odometer, and we reach in that glove box to get the book. And now there's going to be even more reasons why that book is missing sometimes, because nowadays some cars didn't come out with a book, plain and simple. So manufacturers have worked out over the years to save paper, save the forests, save manufacturing costs and all that sort of thing, and printing. Let's just do away with the digital book and to get away with the service book. And now the service history we'll just keep on our database at the main office, where the dealerships can just plug in, connect to the database and just fill it in when they do a service. And that's where it's trending. Some manufacturers already doing it in Australia, has been done overseas for quite a few years already, and there's going to be more and more manufacturers going to the digital logbook. So let's look at the history and the inception of the digital logbook. Believe it or not, the first manufacturer to give it a go was Mazda back in 2006 when they brought out their digital service record, no more book in the car. At this time and at this date, not in Australian vehicles yet. So in Australia, we still have the service book. Remember, guys, we're always a few years behind. But in saying that, from what I've seen and what I've heard, I wouldn't be surprised if you get the latest CX-9, the CX-8, the latest Mazdas, that they probably would have gone to a digital logbook by now. Volkswagen Audi Group, they followed suit in 2008, moving over to the digital service schedule. In 2019, early 2019, they started introducing that digital service schedule here in Australia. So the latest model VAG vehicles, you'll find that there's no logbook in them. BMW brought their iDrive service history into Australia in 2011. So firstly, it was the higher end BMWs, and then they started drip feeding it, and now all BMW in Australia, the latest models, have the BMW iDrive service history. So it's the vehicle that must have iDrive in it, that knob in the center of the console. That's the first prerequisite for those cars. JLR followed suit in Australia 2013, bringing in their online service history, which they have been using for quite a few years. Mercedes-Benz brought their digital service book into Australia in 2016. So they're the main big hitters that have brought it into Australia. And nowadays, Volvo has done it, or the exclusive European brands like Bentley and Rolls-Royce, they've definitely done it. Maserati and the like, they've definitely gone that way. And you're going to see more and more manufacturers look at this and say, that's a great idea, the cost savings, an extra level of deal exclusivity possibly as well, and everyone's going to go this way. So what do us technicians do in the private workshop land when it comes to providing some sort of authentication or proof of service for our customers if we're not in the dealership? Well, let's look at one brand, because there is one brand that we currently do have access with in Australia. One brand has let us in, which is great, and that is BMW, their iDrive service history, where independent workshops can access this database. Not every brand is letting us in yet because they can, because we haven't got those freedom for information laws that other continents do around the world. So what do you need to do? You have to go to the BMW AOS website, which is the after sales online system. And here it is here, guys. Now, the good thing is, guys, this is free. We don't have to pay any money to a certain extent. But if you've never done it, this is what you do. Step one, if you just service the BMW and it's got iDrive service history and you want to fill it out, the first thing you need to do is actually become a BMW service agent. Now, it's no big title or anything. Basically, you have to go on the AOS website. Here's the BMW AOS website there. And not only BMW, but all the brands that fly under the BMW banner nowadays, like Mini and Rolls-Royce and their motorcycles as well. So here's the homepage for the AOS. Go on there and then click on here and just enroll yourself as a registered service agent. So you go in there, what country you're in, business name, ABN number, proof of business ownership, so your business certificate, your ASIC form to show that you're a business owner and a trader and things like that. Phone number, email address, website if you got it, all that stuff. Fill that all out, submit it. Costs nothing, guys. It's free, just a bit of time. And within 48 hours, BMW get back to you and say, yes, congratulations, here's your BMW service agent number. So everyone gets their own agent number. Sometimes they might not let you in straight away. They might want some extra supporting information, but keep doing it. It's free. And now you've got your own service agent number. Once you're in, you can start looking at the service history and filling in the logbook, which is great. So when it comes to service history, click on the next page, service and service history, click on there. And here's an example. What we've got here, we've got a 2011 BMW 520D. So let's say your customer came in and you wanted to see what is the service history, what has been done, what hasn't been done on this car in the past. First time customer maybe. So now you're registered, you're in, punch in the VIN number there and bang, the car comes up if it has got a service history recorded to it. So on this particular vehicle, this 520D, we can see here is the digital logbook. Here's the service history showing the date, the mileage, and who serviced this vehicle. And as you can see, it was done by BMW dealers in Melbourne before coming to us. So that is the digital logbook, so to speak. Now, if you want to see what was actually done on those services, you click on them and it tells us everything. What's interesting, last time the vehicle was at a dealership or recorded or hooked up to AOS was 102,000. So it was after that service. Went in for wiper blades, went in for a recall, went in for brake pads, who knows. But it wasn't a service, that's why it's not there. But BMW will have that information on a different database. All right, so if you want to see exactly what was done, you click on one service one at a time and view it. And what has been ticked is basically what was done. And you can see on that last service at 99,000 Ks that this dealer did, they did the oil, they did the front brake pads, they did the fuel filter, air filter, and the cabin filter. What was the status of it when it came in? Was it due, overdue? How much over was it, or how much was left before it was actually serviced? All that sort of stuff. So we can see a whole lot about the history there. And so you can look at them one by one and ascertain the service history. And that is the AOS database. Once again, you've looked at all that, you've worked that all out, you haven't paid a cent yet, just a bit of time going on that internet site. Now, sometimes, I will stress sometimes, the service history can actually be displayed in the vehicle as well via the iDrive infotainment screen. It's in the book, guys, step by step how to do it. If you get the book on page 13, playing with the controls on iDrive, you can go to service history and you can see the current status of the vehicle. All these things are okay, nothing's overdue. But what you can also see, if you click on that, you can also see the service history. You maybe, I'll say maybe. So this is a different BMW vehicle, and yes, the service history has been downloaded to the vehicle as well, not only on iOS, but on the car as well, showing the date and mileage. The service agent, now the fact that it says BMW here, it was a BMW dealer. If it was a private workshop, it just says other. Sometimes it depends how you filled it out, or when in time you logged into iOS and became a service agent, it may show your business name as well. They keep changing what gets displayed there. And once again, if you want to see what's actually done on these services, if you're just looking at it via iDrive, you click on each service one by one, and you can see the things that were done on that vehicle last time it was in. Now, I will stress, I've already said a few times, sometimes you will see this on iOS. It will definitely be on the iOS website if it has been recorded by the previous service agent. You just go on the website, plug it all in, put down the mileage, and I'll show you how to do that very shortly. The only time it's going to be displayed on iDrive inside the vehicle is if the vehicle, after the service, was then hooked up to that internet site. So just like doing a recalibration, you need a J2534 pass-through device, hooking up the car to the internet, to the website via the data link connector, and then transferring whatever was on the iOS website into the iDrive of the vehicle. Not everyone's going to do this final step. Why? Because this costs you money to do, and you need pass-through device to hook up to the car. But it will definitely be on iOS. That doesn't take much to do. Okay, so how do you fill in the digital logbook? So let's start by, putting the information on the iOS website. So you finish the service, you've got the mileage, you know what you've done, what you've replaced, what you haven't done. Log into iOS using your registered business number that they've given you, your service agent number, punch in the VIN vehicle, and then go to service data, upload a new service schedule, and then just tick what you actually did on those service. Tick, tick, put down the mileage, update. It's as simple as that. Just a bit of time, hasn't cost you any money. And now you filled in that digital logbook. BMW are letting us private workshops in. Now, that next step, what if you want to go the whole hog? What if you then want to transfer that and any other previous service history into the iDrive of the vehicle? Well, this is where it starts costing you money. Firstly, you're going to need a J2534 device, something that can hook up the vehicle via the data link connector to the iOS website. So this is the BMW equipment required. It's called ICOM, and as you know, that's going to cost quite a few thousands of dollars. You might have an aftermarket J2534 device, which might do the job for you. Not all of them will, some do, some won't. Not only that, so you have to make that investment if you want to go this far. Secondly, in order to download from the iOS website into that BMW car, you also then have to pay for an ISTA subscription. So it's a monthly or yearly fee, depending how far you want to go, to be able to download from that website. Whether you're doing a recalibration, you also can get recalibrations from that website as well, and you have to pay for this. So you're going to be up for a few dollars, and I dare say you got to work out, is this going to justify the amount of BMWs in the service? Can I on-charge this to the customer? That's why not every car is going to have the iDrive service history completed, but definitely on the iOS. So once it's all hooked up, and once again in the book, it will show you step by step the instructions to do so, hooking up to the net, going on iOS, and after, when you look at the service history, upload to vehicle, click, walk away, let it do its job, make sure you've got a jumper battery on so the battery doesn't go flat and all that time with the ignition on. And you can update the iDrive service history as well. Now, the only other way, BMW owners, the owner of the vehicle, can also look up their service history on the database if they have BMW Connected Drive app installed on their phone. Now, only the owner can do this because in order to do this, you have to supply proof of ownership. So if you've got a customer that's going to help you a little bit, oh, here's my service history, they can bring their phone, load up the app and show you the service history when they drop off the car. That's going to give you an idea as well. If you're not prepared to look at the AOS or you're not prepared to fill out the logbook and things like that. But the owner can see their own service history via the BMW Connected Drive app, which is cool. Now, so I've showed you the BMW procedure because they let us in. They let everyone in. But yes, there are some manufacturers, Mercedes, Jaguar Land Rover, and some of the others that are not allowing private workshops into the service data bank. So even if you wanted to do the right thing, we're just not letting you in because you're not at a dealership. And they can still do this in Australia because the AAA movement still hasn't passed through yet, the right to repair campaign. So that's causing a bit of a stink, a bit of an upset with some customers. It's also it's bordering on ACCC legislation because it's got a slight hint of deal exclusivity, which they're not allowed to promote. So because of this, this is what has been promised to everyone. Whether you have got a BMW, but you're not prepared to pay someone to do it all like us, or if you've got one of these brands like a Mercedes or a Jaguar Land Rover where the service agent, us guys, cannot get in, what can you do? Well, this is what currently all the car makers in Australia have promised to their owners. So what they said, yes, you can go get your car serviced anywhere. By law, they're allowed to, because if not, you're contravening Australian consumer laws. And if your vehicle has a digital service logbook, but you didn't come to the dealership, went to the private workshop, if you give your customer an invoice, which you will, clearly showing the date, the mileage, and clearly showing the items performed and the parts replaced, if the owner then goes back to the dealership with your service invoice, with all that clear information stipulated on there, these car makers have said, we will fill in the digital logbook for free. So, do they honor that or not? You find out. You find out. So tell your customer that if they don't want to pay you to fill in the logbook, because you should charge us guys, it's going to cost you time, so it must cost them. And if you do the complete iDrive thing, it's definitely going to cost you money. Tell your customer, hey, take it to the dealership. Here's the invoice. They should do it for free. That's what they've promised. If they don't, then tell them to tell you, and there are some organizations you can report to if a dealership isn't fulfilling their promise. So hopefully that helps. What's another way to combat this? Very common sense. This is what a lot of workshops around the country are already doing because they can't be bothered going on the internet sites on the ones they can, or they don't want to go that far. The customer doesn't want to pay you the time and money to do all this for them as well. Once again, I should say it should be an on-cost to the service. What some guys are doing, going back to old school, you can buy generic service logbooks. I believe Gregory's and the like make these generic service logbooks. So a lot of workshops, especially that do a lot of European cars like this, they're buying a whole stack of these logbooks. They put their sticker on the front and they start filling it out and creating a good old-fashioned paper copy service logbook, which you then throw in the glove box. The good thing about that, everyone, you, the customer, potential buyers, have got a quick access, clear service history on what's done on the car. If a new owner gets the vehicle, it's got your stick on the front, it promotes them to return to you, so it can increase more business for you as well. So going back to old school would be one way to fight this new world problem. Hopefully that helps you too, guys. Okay, and that's enough for this webinar. So thank you guys for attending this webinar. Hopefully you got some good, helpful information out of that. And stay tuned for part 2 coming soon. Thank you.